Hi, hello everyone. Welcome to this webinar on deploying multi-cloud modern apps with VMware Advanced Load Balancing on Tanzu Application Service. So Tanzu Application Services was also known as Pivotal Cloud Foundry, and that is one of the ecosystems that we support. So we're from the VMware NSX Advanced Load Balancer team, also known as Avi Networks. We were acquired into VMware over 2 years ago, so time flies. We want to talk to you about, our products as well as the support for TAS, and also known as PCF. So if you're here, thank you for signing up this webinar. Before we actually start this presentation, I just have a few housekeeping items to state here. It's often asked, is this recorded? The answer is absolutely yes. You can get an email afterwards to the on-demand link, and you can watch it again anytime. Also, if you find the content to be useful and your coworkers happen to miss this time, forward the link to him or her, and then they can view on their own time. And also, there's a Q&A window where you could use to type in your questions. We can answer some of the questions while the presentation is going on, but I will ask most of the questions to the presenters after they're done. Now, today, what you will expect is a short and sweet presentations on our value for TAS and Tanzu Tanzu Application Service. But most importantly, Nick is going to give us a live demo on our product, so you can see it working right in front of your eyes. Okay, now we have two presenters today. I'd like to introduce them, Polak Desai and Nick Robbins. They are from our product management team, and I will actually let them introduce themselves a little bit so you get familiar with their voice and face.
Thank you, Lei. Hello, everyone. Welcome to this webinar. Thank you so much for joining us today in the morning. I am Polak Desai. I'm the Director of PM at Avi Networks, now acquired by VMware. I am responsible for everything related to application services. So happy to be here and share our thoughts and experiences around TAS and how Avi or NSX Advanced Load Balancer can help you solve some of the issues that you see in the load balancing environment when it pertains to TAS. Now, throughout the presentation, we'll refer to NSX Advanced Load Balancer as Avi. That's the name. So they're interchangeable names, so please don't get confused when we talk about Avi or NSX Advanced Load Balancer. They're exactly the same product. I would also love to invite Nick to introduce himself.
I'm Nick Robbins. I'm a technical product manager on the Avi team. I predominantly work on automation stuff and setting up demo environments. So if anything goes horribly wrong during this demo, then it's all my fault. And I'm probably going to get a stern talking to from Polak.
All right, so without further ado, Polak, let's start the presentation.
Absolutely. So today we'll cover, from a viewpoint of agenda, we'll cover, some of the challenges that we have seen as far as load balancing is concerned. When load balancers get deployed in a TAS environment, we'll talk to you about, how Avi can help you solve those challenges and problems. And we'll also showcase some of our analytics capabilities, and we'll do a live demo as Lei mentioned. Next slide, Nick. All right, so VMware acquired Avi in 2018, sometime this time frame, a couple of years back, 2019 time frame, and since then, Avi has been the load balancer of choice for VMware. What I mean by that is Avi is the strategic load balancer going forward, and all our deployments from an ecosystem standpoint are leveraging Avi. And you will see the strategic differentiation that we bring to the market and provide our customers using Avi, because it's a rich platform with high level of analytics and automation built in, and that's what we are going to talk about today. If we look at TAS, a TAS platform like Tanzu Application Services provides customers with the ability to create new code 1,000 times per month. So it provides you this platform to deploy applications rapidly. It provides you the platform to create platform as a service environment for your developers, right? It shortens the path to production. So developers did not need to understand the infrastructure layer, but can just push a button and deploy their code. It allows you to manage your day-to-day operations efficiently. It allows you to run your apps reliably at a cloud scale. And of course, it provides you with the security postures required for your applications. This is TAS. As you go ahead and provide multiple applications on TAS, of course, you need load balancing, right? And load balancing is the one that provides certain challenges within your TAS environment. Now, if you look at any traditional load balancer, the customers that we have spoken with have told us that they have limited scale. As you create more and more applications rapidly, it's a platform as a service. So if you create more and more applications rapidly, you're going to see that you quickly run out of steam from your load balancer. You quickly run out of the scale required to operate your load balancers. The vertical scale is limited with all legacy appliances. All legacy appliances are deployed as active standby. Right therein, you are wasting 50% of the capacity because your standby load balancer is not being utilized as much. Plus, there is no analytics and visibility inbuilt, right? So if something goes wrong within your environment, you don't know whether it's a task platform, is it the load balancer, or it's a core router, or is it something else that's going wrong within your environment. There is no end-to-end transactionality in the platform, in your load balancers that support your TAS applications. It is difficult to debug. You have to do TCP dumps on several point products and stitch them together manually to understand what's happening. This was told to us by our financial customers. There's lack of automation. There isn't any way that you can make your end-to-end platform pass, right? Because you will be limited by your least common denominator. In this case, it's a load balancer. So although there's a lot of automation built into your TAS platform, the same automation, if it lacks on your load balancer, you cannot create an end-to-end TAS platform for your developers, because then you get limited by the functionality that the load balancers provide. And each TAS platform, each application that runs on a TAS platform is going to require a load balancer. So now you are limited by what functions the load balancer can provide. And because of the lack of automation, because of the lack of roles and RBAC capabilities within the traditional load balancing environments, you're not going to be able to create that end-to-end experience for your developers. And many a times we have seen that the traditional legacy vendors, they are not consistent across clouds. So you do one set of procedure and processes for one cloud, then you do another set of procedures and processes for the other cloud. Now the onus will be on you as an end customer and user to figure out automation between those two clouds, and then be responsible for making sure that there is consistency across the two clouds as you do your operations. That is not taken care of by the product itself, but it is something that you as an end operator will need to do yourself, which again makes it much more difficult to operationalize a legacy load balancer in a TAS environment. The goal of a TAS environment is to be able to provide applications rapidly, and the traditional load balancers prove to be a bottleneck in achieving that goal. All right, so let's look at some of the key requirements that a TAS deployment requires out of a load balancer. Within a TAS environment, a load balancer typically load balances the core routers. Now, what do you require? As you have more core routers, more applications behind the core routers, you need to scale. You need to do vertical scaling and horizontal scaling so that you're able to support the high throughput. You may have these applications for redundancy purposes built across multiple AZs. So you want to be able to have multi-AZ failover times, and you want to be able to support those use cases. You want to be able to debug your environment. You want to be able to see what's happening within your environment. So end-to-end transactional visibility is important. And it's just not logs, right? You need context. You need contextual visibility, and that's what Avi provides. And we'll talk about that in our demo. But you want to be able to go ahead and look at what is happening from a user standpoint, right? If a request is coming from a user sitting in Japan, how does it translate to an LB? How does an LB handle that request? How does the backend application handle the request? That contextual visibility is required, just not a TCP dump. And then you need all your enterprise grade features. You want to be able to have automation so that you can support a multi-cloud environment. You want to be able to have application authentication, and of course, you do want to have application protection, right? You want to be able to do security across your applications as you deploy them on your task environment, because load balancer is one key element that sits right in front of your applications. Keeping these requirements in mind, you have a choice, right? You certainly have a choice of using your legacy virtual load balancers. As you use your legacy virtual load balancers, there's a trade-off. You will get all the features. It's complete from a data sheet perspective. All the check marks, all the corner cases, all the features you may get from a legacy appliance perspective. But what the trade-off that you will have is simplicity. You would not have any automation. Each individual element will have to be over-provisioned. Each individual element will have to be managed separately, which just increases your operational nightmare. And each individual element will have to be troubleshooted separately as well. So that you would not get the simplicity, the transactional, contextual, and information around your environment if you're using your legacy virtual appliances. On the other side of the balance, you have your open source load balancers. You have your HA proxy and Nginx. And the trade-off there is clear. You would lack the enterprise-grade features. You would not have resiliency in many of the cases, right? This load balancers are not active-active. They're actually active standby, which will, again, limit the scalability that you get from the environment, which will limit the ability to fail over in real time. And then you certainly don't have visibility and automation. In many cases, visibility across these products is a customer's responsibility. What I mean by that is they are responsible for writing third-party tools to understand what is happening in some of the open source products. So the question really is, what is the best solution we can have to satisfy the TAS requirements? So if you look at Avi within the TAS environment, let us show you how Avi can help. Avi by nature as a product is active, active, active. So it can scale out horizontally. As your applications scale within your TAS environment, you have Avi also scaling active, active, active automatically to support the high performance applications. We have global server load balancing, which allows you to have a multi-AZ deployment and efficiently fail across the multiple AZs. So we have active health checks for faster service recovery, and we have geo-aware load balancing as well. I cannot do enough justice to end-to-end transactions just speaking about it. You will see that in the live demo, but we do have end-to-end analytics and logging. What that will give you is contextual information about how the client, how the end user is interacting with the application. It will tell you exactly what is happening wrong within that interaction. If something is indeed going wrong, it will tell you whether it's the WAN that is causing latency, or is it the backend application, or is it the load balancer. That level of contextual information you can see from our analytics. We certainly do have enterprise-grade security features, right? We have WAF and application authentication included in our packaging. So there isn't another license that you need to buy. Once you buy Avi, you get all your features, and we have enterprise-grade application security stack that you can use. We are an automation-first platform. What I mean by that is, APIs are a given. We have APIs. We have enable automation via Python, Ansible, Terraform as well. And then we have inbuilt automation for the different infrastructures that we run on. And this is full RBAC with self-service capabilities. In fact, our customers have successfully built PaaS platforms, end-to-end PaaS platforms using Avi, because we provide the fine-grained RBAC to be able to provide the roles and responsibilities and delineate roles and responsibilities across different developers versus people who are going to operate and operationalize the end platform. So because of our RBAC capabilities, we are now able to provide, give you the end-to-end PaaS support that is required to create an end-to-end platform as a service experience for your developers. You can build out the diagram, Nick. Okay, I'll do a quick overview of the Avi's architecture. It's a software load balancer, and it's derived heavily on the concepts of software defined. We do not use software defined just loosely. We really do have a separation of the control plane and the data plane. The control plane, the controller, which is Avi controller here, is the heart of the system. The reason why it's the heart of the system is because it's responsible for doing, management of your load balancers. Now, I'll tell you just in a minute what it does. If you look at the AVI load balancing stack, it consists of your control plane and the data plane. The control plane is responsible for a couple of things. It's responsible for managing your load balancers. It's responsible for spinning up your load balancers. What I mean by that is it figures out the infrastructure that the environmental infrastructure that your load balancing is running on, and then figures out exactly where to place your load balancer from a resource standpoint, how much resources it needs to give the load balancer. It figures out if the topology is in an active fashion. So that is a policy that you tell the controller, and the controller will deploy your load balancers in an active fashion. It also understands the networking aspects of connecting a load balancer to your applications. What I mean by that is if you have an NSXT environment, it will automate your NSXT constructs, tier 0 and tier 1 constructs, and then it will automatically plumb your environment so that you're able to attract traffic from the client and send it to the backend servers. It is also responsible for populating your DNS with the right FQDN and interacting with your IPAM systems to provide the right VIP address. All that is automatically done by the controller. In AVI, we believe that the job of the controller is to manage load balancers. The job of the load balancer admin is to manage application outcomes, right? So once you give a policy to the controller figures out exactly how to implement that policy in the data plane, right? And it automates the spin up creation, the network plumbing. It figures out exactly how to publish your DNS, FQDN, all of that automatically within your environment. Moreover, it also monitors your environment on an ongoing basis. So if an application requires more throughput, more capacity, it will actively scale out your load balancer. Herein, it meets your task requirements. If your applications increase and the load on your applications increase, you can automatically scale out an AVI load balancer, and that action is done automatically by the AVI controller. We do not require an admin, an LB admin or an application admin to go into a device and then say, okay, now deploy another load balancer. No, it's a policy that's written on the AVI controller, and the AVI controller monitors the environment and spins out another load balancer. The AVI controller also monitors the health of the load balancers on an ongoing basis. So if one load balancer is not performing well, it will just take off that load balancer and create another one. The entire state of the session sits in the controller. So it replicates the state on the new load balancer so that there is no traffic hit and all those actions are seamless to the end user. That is the role of the AVI controller. Now, from a data plane perspective, the local load balancing, the global load balancing, the ingress services and application security, the data plane functions are provided by the data plane, which is known as the load balancers, or in AVI's language, we call them service engines. Those service engines are responsible for servicing the traffic based on the policies determined and directed by the AVI controller. Think of them as brainless systems. They are told what to do and they do it effectively and efficiently. And AVI controller is the one that manages the load balancers. It also manages the upgrade of your load balancers. So all of that is done automatically by the AVI controller. Now, we run seamlessly on all environments. We can run in a bare metal environment, we run in a virtualized environment, and we also run in a containerized environment. And the same level of sophistication and automation extends across on-premises to the cloud. So now you no longer need to, with AVI, figure out what cloud you are running and then figure out a different set of operational procedures for per cloud. It works seamlessly across the both on-premises and the clouds that you're working on. With we have inbuilt automation and analytics, like I mentioned. We'll be demoing this into our demonstration that follows next. Could you please click next, Nick? Okay. And lastly, we have AVI Pulse services on this diagram. So AVI Pulse is a set of SaaS services that allows you to enhance the performance of your load balancers. It does automated help desk ticketing functions in the sense that if there is something wrong within the environment, you basically go ahead and upload all your logs on the controller, and the controller is then responsible for going ahead and creating a case with VMware GS, or if you have application security running in, and if you have IP reputation running in, if the signatures get updated on an ongoing basis seamlessly through the AVI Pulse services. So it provides you a set of SaaS services that you can opt in to use to better operationalize your on-premises deployment. With further ado, I would like to invite Nick to walk us through some of our benefits and also walk us through our end-to-end demo and analytics. Thank you so much, Nick. All over to you.
Yeah, so I think we've talked about a few of these benefits along the way so far, but one of the biggest benefits is the level of automation that's built into the system. Like when we're talking about scaling out the data plane, that stuff's click of a button. You don't have to do any like manual provisioning of any VMs or any sort of extra tickets or anything that you would have to do with any services teams to spin that stuff up. You can just click a button in Avi and that VM will get deployed. And then we talked about the analytics quite a bit. I'm going to show you some analytics stuff in the demo. This is extremely useful. It's probably the most visually obvious thing that shows that we're a good product. You can go in there and you've got all these graphs and logging stuff with all the information you would need from a connection all the way through. Right there in the box, it's already turned on by default. You don't need to worry about needing to export this to a Splunk system and do any sort of analytics. It's just all there right away. And then, like we talked about consistency, being able to deploy the same box across multiple public clouds or your vSphere environment or even bare metal is pretty useful. Your scripting stays extremely similar. There's a couple of little tweaks here and there for things like, because you know the constructs for networks between VMware and AWS, for instance, aren't the same. So there's minor changes, but for the most part, the vast majority of your automation would be identical across multiple environments. This is just kind of a little quick glance about what the UI looks like. We're going to go over this stuff in depth in the demo, but you can kind of see that you get an at-a-glance view of your application where you can see the front-ending VIP, and then in the second column you have the pools, and then you're seeing the networks, and then the individual pool members. You can see that we have one down, and then we give you the reason why. So you can see this one, ARP unresolved. It's because it's a dead server. It's not actually on the network anymore, which is why it's not responding. And then you get these are the built-in graphs I was talking about. We'll show this too, but you can see we can do analytics with that toolbar on the right side. You can actually see the data of what kind of browsers you have, and then there's a ton of these. You can do SSL ones and see the site. You can see ciphers, and you can see the available pool members and how well they're being balanced, stuff like that. And then we'll also show this. But this is the detail I was talking about as far as what you see in the connection. So, I mean, you see a lot of information in here. And along with that, you have all of the detailed round trip times. So you know, like, this is a pretty typical good connection here, other than the fact that it's a 404. But you see that the client round trip, which is what you expect, would be longer than your server round trip and your app response time. So, I mean, this is a fairly good looking connection, other than the fact that it's a broken link. So we'll get into that a little more later. There's a couple different scenarios for how to balance this across availability zones. There's a couple different, the two major options we have are Anycast for using BGP to advertise the VIP, and then Anycast to get this across your different availability zones. And then you can use Avi's built-in GSLB. So you get pretty good performance with ECMP, and you know it is an open solution, or with Anycast it is an open solution. You wouldn't need to deploy any infrastructure to handle the GSLB load balancers, because you do require running a service on the Avi SE, which takes resources and takes away from your service core count if you want to run GSLB. So this kind of gets you away from that. This definitely works, and you can scale this pretty well. But if you do GSLB, which would be the Avi version, the Avi way, then you would get that active health checking. So you wouldn't have to rely on the route to be pulled, and you would get more active, like more of a detailed, it's not just a network level health monitoring, you can actually get application level health monitoring. So if your web server is still up but is responding with the incorrect response code, we can pull that out using GSLB, which we wouldn't be able to do using Anycast. All right, so let's go a little bit over the product itself. So like we talked about before, so we got analytics. Let's do past 6 hours. You can see we got this steady graph of application traffic coming into our VIP. You can see that we've got these breakdowns of colors, which are the different levels of the communication, which I showed before, the client round trip, server trip, whatever. You can see them in the bar. But as you're seeing, it's pretty standard traffic pattern, and then every so often we get this big old spike in time here, and this is the kind of stuff that you can visually see, that you know every day at this time, you have this same spike in traffic. So it gives you the opportunity to kind of quickly go back to your server team and say, are there jobs running, like are there backup jobs, or there's some sort of replication job that happens at this time, because we're getting this kind of slowness, and it's kind of easy for you to tell that this is, so you see app response goes from 37 milliseconds, now it goes to 76 milliseconds. This is likely something in your web server. So you can kind of tell that it's not a network related issue at this time. So it kind of helps you pinpoint and troubleshoot quickly where a problem may lie so that you can do deeper investigation. And then from a logging perspective, we're talking about those analytics. So we've got the concept of significant and non-significant logs. Normally, non-significant logs would be turned off unless you're doing troubleshooting. Those are all your good traffic, the normal 200s that all happen within a reasonable amount of time, any of your, all of the stuff that works. So we don't want that necessarily clogging up the logs. So we kind of keep that stuff off by default. But if you need to do debugging, you can turn that on. We have it turned on for this demo system. It does greatly increase the amount of logs. But significant logs are the ones we're worried about, right? These are your like your 300s or your 400s and 500 error codes. Anything that takes longer than a certain amount of time, we've got configurable times that will, if you've got an application runs slow, you can kind of raise that time up a little bit so that you don't always flag that as a significant log. But for the most part, like these 800 millisecond requests and stuff, that's bad. That takes too long. But the interesting one is we got some 404s here. So we got a search bar, kind of Google-ish, can hit the button and it's going to load all of the 404s it's seen over the past 6 hours. So they're coming from everywhere, but they're all commonly the same file, right? So we got this logo missing once in a while. We don't know what the problem is. So we can kind of do some analytics over here to see these server IP addresses. And we see that 98.2% of the 404 logs that have happened over the past 6 hours are happening from one server. So like that fast, you can tell that that one's likely missing your file. The other ones are probably people putting in the wrong URL or whatever. But the 404s for this logo are likely all coming from this box. So you just saved yourself how much troubleshooting by being able to look at that at a glance and say, here's the broken server, tell the server team they upload the file, problem goes away. So that's the kind of stuff you can do without doing a TCP dump, without doing external log analytics. That's all on box, built in. So some of the other stuff that you'd see, like for instance, if you had WAF turned on and you're getting an application attack and you see some of these the attackers coming in and we're blocking it based on our rule set, the log and the information in the log that gets generated is pretty comprehensive. Like you can see which CRS rule they're hitting. You can see the detail of what command or what they tried to inject in the URL as a query parameter, and you can, so these are the kind of things that you can go back and tell your application team. And so you've blocked it already, but you can tell them maybe we have a vulnerability we need to tweak or something like that. So this, like I said, it's pretty rich analytics in here. And then to talk a little bit about our automation, we talked about being able to easily, quickly scale out horizontally. So we've got an application here, it takes a fairly steady load, but the service engine it's running on is running at max CPU, which is probably not a good thing. You don't have a lot of headroom with only 4% CPU left. So you can go back to your scale out VS, and we've got these buttons up here where, so the three buttons we have, scale out, scale in, and migrate. Scale out, scale in, fairly obvious. Migrate is like when you're thinking you want to do some sort of maintenance. So you want to move this off of the service engine for whatever reason, you can hit this button and send it to a different service engine. But we're going to scale out and see if we can maybe increase the performance. So we've got one SE that's already spun up. That's the one it wants to use. We have the ability to create more, but we're going to leave it on this one right now. For this particular one, we limit this to only having 2 SEs so people don't get carried away and they're during the demos. But we can hit scale out. So you can see right now we're on a single service engine. That's our primary. And what this is doing now is telling that other service engine that it needs to connect a VNIC up to this network and start handling traffic for this. And then just like that, we're on to 2. So if we start watching this guy on our real-time analytics, we'll start seeing a drop in throughput and we'll start seeing a drop in CPU. It's not much yet because we just did it. But so you can see that we've got the other one handling some of that load now. Now, beyond just having a busy service engine, the other time this would be useful is if you know you have an event coming up, using the good Black Friday example. So in advance of Black Friday, you can scale that up 2-3 more SEs, and you know you're covered as long as your backend can handle it. This would also be useful. WAF tends to take a fair amount of CPU if you don't have lots of proactive rules in there. So that's a good way to see if you're all of a sudden getting a lot of attack traffic and it's starting to run up your CPU. You can quick scale out while you figure out what's going on or how to block it. So it's pretty easy to give yourself some more performance without taking a lot of impact. And then, you know, just like we did before, we can go back and scale in. Have it select automatically. It's going to drain connections. If you did not have a service engine waiting there, it would spin up a new one. That we don't usually do that on the demos because it takes a few minutes. It's got to deploy an OVA and connect to the network and all of that stuff. But that's part of the beauty of the automation of Avi, and that's all kind of done through our cloud connector. So the cloud connector is the magic of the Avi system. That's what enables all of that data plane automation. So in this case, we've got a couple different clouds hooked up in this one. We've got an AWS cloud, we've got a vSphere cloud. We're actually connected into the vSphere with write permissions. We've got a user who can spin up VMs, whatever. And then when we decide we need more load balancer capacity, we tell that vSphere server to spin up another one. We send the OVA over to the ESX server, and you know, get a few minutes, however fast your infrastructure is, we can have a new VM up and serving traffic. And this is all good automation. This is the built-in automation stuff that you don't need to do. We do have the ability to obviously automate with all of the common public or popular tools now, like Ansible and Terraform. This demo system is actually built from Ansible. I use Ansible Tower to run nightly jobs on this to kind of clean up after sales guys when they're out playing around on customer demos. And those jobs run every night. The SDK gets loaded, and the collection for Avi gets loaded, and it just runs all the commands to clean everything up. So it's very handy, keeps these things running fairly smoothly. And yeah, so we pretty much have the ability to do all sorts of automation with that stuff. What else haven't I talked about? So you can see our traffic went to normal when we scaled back in. We're back to running on 1 SE again. We talked about WAF, we talked about analytics. So in the case of a PCF environment, when you're running Avi in front of it, the pool members are going to be the Go routers. So we have the layer 7 virtual service, which is kind of the deep HTTP analytics would sit in front of a Go router, and then we can do the layer 4 virtual service that would sit in front of a TCP router. So those would just be the pool members of those different types of things. When you're doing layer 4, you obviously don't get quite as detailed of analytics just because we're not doing protocol decoding at that point, but you still get quite a bit. I think, where do I have a layer 4 one? So I mean, you still get to see some of all of these are from me testing Horizon, but so you don't see a lot of that stuff, but this is actually a bad one to look at. But the idea is that you'll see the same analytics graph and the same logs graph that you would get in the other one. You would just not have all of the deep HTTP connection details in that. And then the tree view thing we showed it in the slide, but you can see it again here. I mean, you can expand all of these out, see the network they're on, see the servers, you know. This one using HTTP policies for content switching actually has multiple pools. So you can see the breakdown. Certain URLs will go to this pool, certain URLs will go to this pool, and that's all done through a policy. These are the kind of things that used to take things like iRules to do. You don't necessarily need to do that in Avi. Most things that required iRules can be done as HTTP policies. You don't need any extra scripting for that. Lots of different ways to handle that. I can quick show one of those. So we've got these rules. These are network security rules. These are very low level, like layer 3 type stuff where we can do rate limiting and deny based on country lists and stuff like that using the GeoDB lookup. HTTP requests is kind of where it starts getting more capable. So you can see if we have a path information, it does content switch. If you want to do new rules, there's all kinds of things we can match on, versions, methods, like get, post, headers, cookies, query parameters, all of this stuff we can match on and then do these different actions, redirect, rewrite, stuff like that. So I mean, pretty common load balancer features, but you can see you can do that all through a little quick UI. And like we talked about earlier, with it being multi-tenant, if you had a developer put out an application in their tenant, they could actually do these kind of rules and tweaking and testing and doing stuff in this by themselves. They'll probably break something and ask the network people how to fix it anyway, but at least you gave them the opportunity to learn. And they can do this without wrecking the underlying system. Like they won't be impacting that cloud connector. They won't be impacting any of the data plane components. And we can do that on request response time. Yes, we'll discard those changes. Data scripts are our iRule equivalent. So we can, if you have something that doesn't fall into that category that can be done with a request to response policy, we can usually do it through data scripts. We use Lua as the scripting engine for that because it's fast. So we can kind of handle a lot of those really niche use cases through data scripts. And then we've got a data script library on GitHub with some of the common things that people might want to do with them, kind of some examples, things that would kind of help you to see how you'd want to do it yourself. And then we talked about authentication without the backend knowing about it when we were doing the slides earlier. So we have the ability to be a SAML identity provider. So service provider, sorry. So we can connect SAML up. You can use Workspace ONE as your identity provider. We would fire this SSO policy up in front of your particular application, and it would be authenticated through Workspace ONE, and the app doesn't even need to know the difference. If your app does have some different level of like RBAC or whatever, there you can send SAML parameters to the application. But this is all stuff. I mean, your app doesn't need to be application aware to be able to use this. This is basically, using a SAML gateway right in front of it, and you don't need to do anything special with the app. So that's part of that enterprise feature set. We talked a little bit about analytics, logs on and off, logging all headers. I didn't show you headers. I should show that real quick. Real-time metrics. This is the kind of stuff, we have all of these knobs on for the demo. You wouldn't normally do this in your environment unless something was broken, just for performance reasons. Having real-time metrics on and having non-significant logs on obviously does have a performance impact, but it's useful for troubleshooting. So, you kind of turn it on demand when you need it, take a look, and then everything's cool. You figure it out real quick and move on. The advanced stuff. So we talked about analytics. What was I going to show? I forgot what I was going to show. Okay.
Actually, Nick, we have some questions for you and Pollock. Do you think it's a good time for us to entertain some of that?
Sure.
Yeah. So the first question is from Brett Drew, and he said, he's asking, do you need to deploy NSX in order to use Avi?
You do not need to deploy NSX to deploy Avi. In fact, we supported all of the public clouds prior to NSX, so all of that stuff still works, and we're not going to give that up anytime soon. So even though we share the name, it is not a requirement.
Yep.
To add to what Nick mentioned, we have several customers who are using Avi in production today. With our NSX, so as Nick mentioned, there is no requirement whatsoever to have NSX. It's predominantly a marketing sort of name. Yes, we do work with NSX, but do you need NSX to deploy Avi? The answer is no.
Yep, absolutely. The other question that from John is, you show GSLB and WAF and analytics. Is that included with the product, or I need to buy different licenses?
So Avi's licensing mechanism is very simple. We have one license and you get all the features that we just showed. That we do not have license tiers. We have one Avi Enterprise license, and once you buy that, you get all the features, GSLB and all other features, WAF that we mentioned in the slide and in our presentation today.
Mm-hmm. Okay, and then the next question is a bit long. If you guys, Nick and Pollock, you can see in the Q&A window as well, but I'll read out to the audience. From Ravinja. So you ask, does the GSLB do intelligent load balancing, like forward a service request to the most optimum instance of the service based on the criteria that you can determine, like response time, thresholds, number of connections, geolocation, or any combination of those? How is the decision made? What information is available to the GSLB to make that decision? So very long question, but detailed.
So different parts of the load balancer will do different parts of that. GSLB itself is going to do mostly the routing based on whether or not something is up and a certain level of degrading. It'll do all of your geo based on a publicly available geo database. You can also do a topology database if you want to redirect people differently than that geo database. That's handled by the GSLB engine. The local load balancing engine would handle all of the stuff based on optimal. So that's part of what we would call our passive health checks. So we've got passive. So let me open that up real quick. So you got a pool. Your pool's configured with a health check. We've got a passive health monitor. We got an active health monitor. The active health monitor is your traditional monitor where you're actually looking for a response to make sure something's up. Passive health monitor is watching the quality of the connection. So if you have one server having a slower response time than the rest of the servers in the pool, that passive health monitor will tell the system to start kind of, I won't say fully draining, but it reduces the ratio of connections that server will take to the rest compared to the rest. So that's kind of where we're talking about being able to intelligently determine which ones are operating better and be able to reduce the health of that one. So that kind of happens automatically on the local side. So the GSLB one is going to see whether or not overall that's an appropriate site to go to, and then the local one will be able to tell which of the members of the pool are best suited to answer the request. And yes, we have all criteria for thresholds on health scores and all that stuff. Geolocation, yeah. And we got all the typical load balancing algorithms. So this is kind of the different stuff you'd be talking about with least connections, stuff like that.
Okay. Hopefully, Ravinja, it answered your question. We have another question from Keith. He say, how is performance without hardware acceleration on a hardware appliance?
So hardware acceleration is mostly designed around RSA ciphers, and RSA ciphers are the old school. So we would tend to have you use an elliptic curve cipher. So if you do EC certs and EC ciphers, you actually use a hardware acceleration of the processor. The AES instructions on the Intel or on any of the modern processors are kind of basically like our hardware offload engine. So we get very good performance out of EC certificates. We obviously can't keep up with the hardware RSA card, but it's very easy to scale us out to accommodate that if you still have legacy certs out there.
Yeah, and also, Keith, just to clarify that our platform is 100% software. Yes, we do have customers who deploy our software on a hardware appliance, but that's rare. Most of our customers actually just deploy the software directly and then be able to take advantage of the horizontal scale, the elastic fabric that we can provide through software-defined system. Okay, all right, move on. Sanjeev has a question. When to use BGP Anycast and when to use DNS for GSLB? Can BGP Anycast-based solution also be used across regions?
So it's pretty much up to you on which one you want to use. It kind of comes down to features and cost. So you can use BGP Anycast as across regions just like you can with GSLB. You just don't get quite the same level of health checking. But you do have to pay to run GSLB from a service core perspective. So basically when you're running GSLB, you need to run a DNS listener on those load balancer. The service engines are data plate components, and when you do that, you're taking capacity, so that ends up you kind of end up with a performance hit, which means you would need to buy more licenses or more service cores to cover that hit if you were already at capacity or whatever. So I mean, basically it comes down to cost versus functionality, like everything else. They both work well in this situation, so you can use either one.
Yeah, okay. And then Keith has a follow-up question. Does Intel and AMD compute work? I guess that's what he's getting at. We might have misinterpreted what he was asking earlier.
Yeah, you can use either processor. They both work fine.
Yep. And then Sadiq, the session is being recorded right now, and you will get an email, with the on-demand link. Again, you can forward it to your coworker, as I stated, that if they miss this live time, they can always watch it on demand again. So great. Nick, if I would ask you, I think that's all the questions, and thank you for all the thank you from all of you. If you go back to the last slide, I just want to do a little bit advertisement. So we do live the last slide.
Yeah, sorry.
Next one, please. And then we do want to make sure that you get the next steps, right? So we do run webinars very frequently on avnetworks.com/webinars, and you can learn about these different topics, and you can view a lot of the topics on demand as well. But we really want to get your hands dirty. If you're kind of a hands-on person, we have rerun workshops where you can actually experience the product yourself. So because we don't need to ship a hardware box to you, so you can actually test drive our products and see for yourself. So do want to direct you to this avnetworks.com/workshops. We offer two types of workshop. One is a 90-minute commitment where you did a little bit more introduction of Avi platform, and then you have 60-minute lab that you can actually do and complete yourself. And then the second type of workshop is a 4-day workshop. Every day is about, I believe, half day, like 3 hours or 4 hours a day. And so it is a commitment, but you get to actually walk through with our instructor live. And we go into a lot more details into the analytics, the WAF, the GSLB, and automation capability that Nick just kind of flashed through. You will actually get experience to do it yourself as well. And then including along with a deep dive architecture workshop, so you really understood how our product works. The other things you can always, reach out, and then we can do a more custom demo. Let's say, hey, I have this particular scenarios, and I want to know how Avi can help us solve the problem. Reach out to us to schedule a demo. Yeah, so that's kind of a little bit the advertisement here. Anything else we miss, Polak and Nick? Otherwise, I think we can conclude.
So a quick plug for automation. She's talking about the workshops. I have scripts that build these workshop systems out. I've seen them they've put 1,200, right around 1,200 users and tenants into a controller, which can be done in, I don't know, maybe 5 or 10 minutes with the script. And then after they go through and spend an entire day making stuff and breaking stuff and leaving behind a whole rat's nest of things, it's about another 10 minutes to clean all that up. So the power of automation really shows itself in workshop
Yeah, and Nick
systems.
is the man behind it, but he's making his job easier with automation.
Yes.
Our system is 100% REST API enabled, so you can do a lot of things with automation. Talk about scripting, actually. I do want to pop up one question, which is often asked by our customers or potential prospects, is I have F5 and I have a lot of iRules on it. Can you help me to convert? And the short answer to it is yes. And we have migration tools that can help you to convert most of the iRules. And of course, there are complicated situations where we have professional services team that can step in and help. But most of the rules can be converted from F5 to us fairly easily. All right. Okay. If we don't have any, I don't see any live questions coming in. So thank you, everybody. You will get the recording and the slides soon after, and feel free to share, this rich kind of this webinar as well as other resources we have on our website. All right. Thank you, Nick and Polak, and thank you for the presentation demo.
Thank you.
Have a good day.
Thank you, everyone, for giving us the time.
Yep. Bye.
Bye.